Good morning.
Good morning. Good morning.
Mhm.
Got a few people still coming in. But good morning, everyone. Good morning. Hope all is well. Hope everyone's doing okay. Sure this
Do you take attendance?
Yeah, I do take attendance, but I really look more so at I mean I check and see what's going on in Zoom, but really my math lab, for those who may miss, a lecture, my math lab will solidify your attendance. So I look at both.
Okay.
Did you have a particular question, a specific question with regards to
No,
that?
I mean I sent you an email before saying that I had to do observation hours.
Mhm.
I'll be missing out today and Thursday. But do you like have extra help after hours or so?
Yeah, just shoot me an email and we can see what time, we want to, not if we want to see how we can match up our schedules and see what time are available for both of us to meet, and we'll go from there.
Yeah, because some of the stuff is confusing and I'm getting behind with
Hmm.
this work thing from other class.
Hmm. Yep, shoot me an email. We can set up a time that we can meet.
Okay, thank you.
Yep, not a problem. All right. Anybody else? Any other questions before we go anywhere else? Last class we closed out chapter five, not chapter five, chapter three. I believe that was this class. Let me make sure. Yep. Anybody have any questions out of, chapter three, chapter one, chapter two? Like trying anything, get stuck? Everybody good so far? Straight. Let me take a look at one thing real quick. Okay. Don't know. So, unless I'm assisting in the chat. All right. So, let's look at, since everybody's okay, let's do a few. hmm, Chapter four sections. We can at least do two sections today, and then call it a day. But once again, make sure you guys are on top of this stuff. Stay on top of this stuff, because it's summer. We kind of got to move a little faster than we would in a normal 16-week session. So you don't want to get too far behind. All right, so 4.1, visualizing variability with a scatter plot. Let's see, do I want to go to the other one? And I'll just write this out. All right, so scatter plot is a primary tool for examining two variable relationships when both variables are numerical. Each point represents one observation. I'll leave it like that. All right, and so when studying scatter plots, we look for trend, which is like your center. You know, where's the center of what's going on, or how, what's the pattern? I think pattern would be a better one when they said center, but here's some information. What in the world? All right, that makes sense. But all right, the trend, which is like your center, the strength, which is the spread of your data, how much your data is spread out, and then the shape, you know, it's just the shape. Decreasing. All right, so trend is the first one. That's the general tendency of scatter plots of the scatter plot as you scan from left to right. So it's always from left to right, just like when readings from left to right. Increasing trends are positive or called positive associations or positive trends. Decreasing trends are called negative associations or negative trends. All right, so I'll do that. So I forgot to even show you just a general example of what a scatter plot looked like. Um, Really, I should have, did something like that up here, when we first had it, just, and I would have just did something in general. Of course, each dot, and that's what we're talking about here. Each point represents an observation, and so it goes back to graphing, your XY plane. And so, but I forgot to do that, so it's all good. But just a general scatter plot would just be the first quadrant that you dealt with, and then just points that represent each observation. So here we have an example of a positive association and then an example of a negative association. So if you notice, um, going from left to right, this goes up, the pattern goes up. So that's considered a positive association. And same thing here, going from left to right, this association, the pattern goes down. So that would be a negative association or example of a negative association. All right, and then these next two, just an example of one not having a trend at all, and then the other one, they consider that a changing trend. And just to reemphasize, when it comes to a scatter plot, you would have numbers that will tell you where to plot. Right now, just doing general stuff just to give you an idea as to what these will look like and what you'll be looking for. All right, can we scroll up? Hold on one second. Just that's all done now. All right, so when it comes to strength, weak associations result in a large amount of scatter. Large amount of scatter means that the points have a great deal of spread in the vertical direction. Strong associations have little vertical variation. All right, scrolling up. All right, and then just a generic example of a weak association and a strong association. All right, going to shape. All right, so we're looking at shape. It's the simplest shape for a trend is linear. Linear trends are quite common in nature. Linear trends always increase or decrease at the same rate, and they are called linear because the trend can be summarized with a straight line. All right, so down bottom, we have a linear trend versus a non-linear trend. So like I said, just giving you a general example of what you should be looking for when you talk about a linear trend. And we will be focusing on linear trends. So the techniques that we use in this chapter are focused on linear trends. Linear trends.
I have a question.
Hmm.
Non-linear trend and the changing trend looks pretty much the same. Did I miss that part?
No,
Or
they're the same. Yeah, just
oh, okay.
remember the other one we were focusing on. What were we focusing on? Shape. No, this is shape. So then we're talking about trend, and
Okay.
so here we're talking about
Linear.
linear. You know, so yeah,
Okay.
it's the same thing. Yeah. So just like
Okay.
when right here, if you look at linear trend, here we're talking about strong association. We're talking about positive. You know, what I'm saying it's the same thing. It's just that depends on what you're focusing on at the time.
Okay. And on like a test or a question is gonna specify that? Like, oh, we're talking about linear, we're talking about
Well, all of it is the same thing. So, you know, it depends on what they're asking of you. Like here, we're talking about linear, but you can also say this is it has a positive association. You see what I mean? So it just depends on what they're asking you. Just because something has a positive association doesn't mean that it doesn't have a linear trend. You know, doesn't mean it can't be best summarized by a straight line. So,
okay. Thank you, Professor.
yeah, not a problem. And just to throw this out here, just emphasizing what she's saying. You know, if it was going this way, you know, this would still be linear. It's just that now it has a negative trend. So yeah. So it just depends on what you're talking about at the time. Yep. So good observation. Good observation. So just reemphasizing that this book focuses on linear trends. So the techniques used in these sections would not help you for a non-linear observation. You know, if you were to have non-linear situations. All right. Everybody good before we go to 4-2. Trying to see exactly how much I want to give you guys. This notice for myself. Might be 4-2. 4-1. All right, so let's look at the correlation coefficient. So it's a measure of strength and direction of the linear relation between two quantities or two quantitative variables. So remember we talked about before how population has different symbols. I think I mentioned, yeah. Mention that population has different symbols versus your sample. Um, Greek letter rho, kind of look like a P, but Greek letter rho is your population correlation coefficient. But for us, the one we will be using is R, which is your sample correlation coefficient. All right. So just like we did, don't worry about this 4142 stuff because our sections are different. But just like we did before with the standard deviation and the variance, you want to find a calculator website or app that can reduce the correlation coefficient and the regression line. And I'll give you an example that you can use in order to do that. And same thing, just like before, if you want to use easycalculation.com, that'll do it for you. If you type in correlation coefficient, easy calculation, or regression line, easy calculation, then that would be the first one. Once again, you do not have to use easycalculation.com. You can use, whatever you like. But I'm not asking you to purchase anything. Shoot, if you want to, you can do it by hand if you want, but I'm not holding, holding you responsible for that. All right, questions on that before we scroll up? All right, so let's look at some properties of the correlation coefficient. It is between -1 and 1 inclusive, so that means it can be -1 or +1. If R is equal to +1, then a perfect positive linear relation exists. If R is equal to -1, then a perfect negative linear relation exists. The closer R is to +1, the stronger the evidence of a positive association. Closer R is to -1, the stronger the evidence of a negative association. If R is close to 0, then little or no evidence exists of a linear relation. And R close to 0 does not imply no relation, just no linear relation. Remember, we're looking for linear relations. So it is a unitless measure of association. And then 8, I believe that's the last property. Yep. It is not resistant. So that means it is affected by outliers. Let's copy 6. So here's some generic, once again, generic scatter plots, and then what R would be, or what R could be, depending on how you start to spread away from your perfect line. So notice in the first one is a perfect positive one. So it's a perfect linear, positive linear association. So then once you start to deviate or spread or come away from being a straight line, you start to move away from being positive 1. So then you have 0.9 and then 0.4 as you continue to spread away from that straight line. It's still a positive association because all of your trend is still going up or increasing, but you're moving further and further away from 1 and closer to 0. The same thing happens with the negative 1. You see right here, that's our changing trend. There is a trend, but it's not a linear trend. But R will be close to 0 because remember that 1 and that negative 1 represents a linear trend or a linear association. And then of course that last one is going to be close to 0 as well, not having an association at all or a trend. All right, any questions, any questions? Everybody still copying? All right. I don't think you guys are doing that. Hold on, I want to make sure. Get that. All right, let's go back. So a few things I want to point out. You want to find me a good example to emphasize this? Okay, let's go here. Um, between. And go between first. All right. So correlation does not mean causation. I probably should have underlined that instead of making it an asterisk. Just saying that correlation does not mean causation. So do not conclude that a cause and effect relationship between two variables exists just because there is correlation, no matter how close to positive one or negative one that a correlation may be. So just an example of what we mean by that. Mm, Between, okay. All right. So a politician wants to close down liquor stores in the city because there was a positive correlation between the number of liquor stores in a neighborhood and the amount of crime. So what it's saying is that, like this. Um, All right, so even a correlation near positive one is not enough to conclude that change in one variable, the liquor stores closing them down, will lead to a change in the other variable, which is, the crime rate. So, because there could be other factors, and more than likely, there are probably other factors that will lead to that. If you close down liquor stores, but you haven't put a stop to, drug trafficking. I mean, it's possible that the crime rate will still exist. What about the educational system? What about the poverty rate? Are there decent jobs? Are people being paid decently? Just different things in that area. Jobs like working at McDonald's. What is minimum wage in that area? All those type of things could affect why crime rate is high. And just closing down liquor stores may be the least of your concerns when it comes to something of that nature. So they just want to make sure that we put it in proper context, and don't jump the gun. All right. I should have did this one first. It's all good. All right. But it's all good. Doesn't matter. But I guess if I was doing this, I probably would do correlation, coefficient, and context first. So let's give an example of that. Make sure we're okay with what it means. Um, I was like, oh, that's positive. All right, so the correlation between the number of Google searches for zombie and vampire is R equal to 0.924. So this would mean that those who Google search zombie also tend to search vampire because R is positive and close to 1. So it's just talking about the trend and the tendencies of these or the pattern of these two numerical variables. If it was negative and close to 0, then that means those who Google search zombie would not, that the trend goes down. So normally they don't do, or there's not a connection as far as them going to zombie, going from zombie to vampire. Evidently their interest lies elsewhere. So you could say that they're not really, interested in the same things. But this would say that those who are interested in zombie are also interested in vampire. And of course, it's not perfect. So there are some people who are not. But if it was a perfect positive one, that means that everybody who they observed, Google zombie and vampire at the same rate and stuff like that. So, all right. Questions. All right, so that is it for 4.2. Let me check something out. Okay, so before we leave, though, I just want to give you an example or something you can use to find some data values you can use to find your correlation coefficients. So let me take a picture of this and put it on the other set of notes. More than likely, yes. But that's what I've done before. So more than likely, yes. But you guys will be able to create a note sheet or something like that, and there will be a review created that you'll be able to, streamline your studies and know exactly what's going to be on the test as well. So, So I want to find the correlation coefficient between the club head speed of the golfer and the distance the ball travels. So we got 1, 2, 3. All right, so we have 100, 102, 103, 101, 105, 100, 99, and 105. So club head speed, talking about how fast, basically how hard he's swinging the golf club. And then how far the ball travels, 257, 264, yep, 274, 266, 277, 263, 258, 275. And these are 8 observations. So when you look at this, you got 1, 2, 3, 4, 5, 6, 7, 8. Yep, just making sure. All right, so it's 8 observations, not 16. So these go hand in hand. That was one observation. Then the second one is another. In other words, he swung his golf club 100 miles per hour, and the distance the ball traveled was 257. So these are only 8 observations, not 16. And also, which is what we'll get more into detail on next section. This is called your explanatory variable. And this one is your response variable. Like I said, we'll talk more about the difference between the two next section when we get into regression line. All right, everybody good before we go to the website? One second. There we go. So once again, I would Google correlation coefficient, easy calculation. And so normally, like I said, when you do correlation coefficient or whatever you're looking for, easy calculation or easy calculator, the first one is the one I normally use. All right, so notice you can add columns and rows. No, add rows, not columns, and take them away if you want. But we need 8 rows. A little slow today and see some stuff out. All right, so you have to be careful with inputting information for your correlation coefficient or your regression line, because if you mess up on one digit, you will get a different value, and I'll show you that in a second. So it's 103, 274. All right, so we got 100, 257. Like I said, I'm just making sure my data values are in there correctly. 103, 274, 101, 6. All right, so we have our 8 observations, and then the correlation coefficient is right here. So make sure you pay attention to my math lab. What they asking of you, I think they normally ask you for 4 digits. Um, so, just make sure you're careful. They may ask you for 3, but we have 0.9387. Make sure you round correctly as well. But, well, let me do this. All right. So like I said, make sure you're careful with your digits. If I change this 7 to a 6, notice that gives me a totally different number, 0.9444, so a completely different number. If I take it back to a 5, now it's 9387. So one digit off can change everything. So make sure you're careful on putting in your information, because 0.9444 is way different than 0.9387. All right, questions on the calculation of your correlation coefficient? So I just went ahead and just, that's what our answer would have been. All right. Any questions or concerns, comments, anything, anybody? All right, so that's,
Chapter 4 assignments will be posted in my Pearson today.
yep, I'm trying to get it in there for you today, yep.
Okay.
All right, anything else, anybody else? So that's 4.1 and 4.2. Next class we'll do 4.3 and 4.4. And that'll be it for chapter 4. So don't forget, every day is opportunity for questions. If you guys have them, notice I'm not using up all of our class time for lecture. So that's by design, so you guys can ask your questions. But it's up to you. If you want to, like one of your classmates mentioned at the beginning of class, set up a time to meet outside of class, we can do that as well. But just let you know that time is there for you to do so. All right. Any questions or concerns before we close out today? Good. All right. So you guys have a good one. Be safe. Take care. And I will see you on next class.
Thank you. Have a good day. Thank you.
Thanks. Thank you guys. You have a good one. Take care.